Okay, we're on to 2-4, opposites. Hope you enjoyed the lesson on puzzles and that went well for you. I think that's kind of a fun thing to do with algebra. Here into opposites, we're learning some really important properties of numbers that apply to all numbers. We have some vocabulary that you need to know for this. You need to understand what an additive inverse and an opposite are. Our first property is the opposite of opposites property, or sometimes we call that one the op-op property. What this one is telling us is that if I have a number and I take the opposite of it, I get the same number. So let's take a look here at what that might mean for us. So let's pick a number. Somebody got one? Okay, yeah, -5, that's great. So -5, if that's our number, then that's a -5. The opposite of -5 is a -5. So negative times a negative would be a positive. That would be 5, and that's the opposite. And then if we take this, a negative, -5, and that equals -5. And this is my op, and I'm back to what I started with. You'll notice that here there are three negative signs. A negative times a negative is a positive. Negative times a positive is a negative. So that's our opposite of opposites property. It's important to remember when you see it that we can get back to where we started from. Now, when I did this, I actually made use of a property we haven't talked about yet, but we will right now, which is the multiplication property of -1. And right here, effectively, I multiplied both sides of the equation by -1. Did the same thing to both sides. Let's get another number. Let's say I have 7. And I want to do the op-op of that, so the opposite of 7 should equal 7. So 7 equals 7. -1 times 7 equals a -7. So this is where that negative comes in. And a -1 times a -1 times 7. Negative times a negative is a positive. I'm back where I started from. This is the multiplication property of -1. This is convenient in multiplying and in manipulating an equation if I would like to change some term into a negative value. I multiply by -1, I make it negative. If it's an equation, such as these, what I do to one side I have to do to both sides of the equation. Okay, our next one is the opposite of a sum, which is that if we have a term a and b, the opposite of the sum a plus b is equal to the opposite of a plus the opposite of b, or opposite of a minus b. And lastly, we have the opposite of a difference. Same kind of idea. The opposite of a minus b is equal to the opposite of a plus b. Now the reason I say opposite of a or opposite of b is that we don't know what its value is, and so it's important to refer to it as its opposite rather than a negative. This prevents some confusion. Let's look at some choices. Let's say I have some variables, x, y, and z. If x equals 5 and y equals a -9 and z equals -2, then the opposite of x is equal to a negative 5. The opposite of y is equal to, well, it's the opposite, so that's 9. It's a negative negative. The opposite of z is equal to 2, because it was originally a negative term. So it's important to think of them as opposites, not negatives, and it prevents the error of writing something and thinking, oh, it's negative, and then forgetting to have this sign act on it. So it's a useful construct to talk about it in that way. Example 1 is here. I'll be going through a similar example in my lecture. The guided example is right here. I'll do another one when we come to it in my lecture, but let's take a look here real quick. It asks us to simplify x plus 6 minus 7 times x minus 3. What's different here is we've got a value greater than 1 there. Where up here we have that's just a 1. We don't write it because it's just 1. But it's a negative 1 times 3x plus 7. And here it's just simply negative 7 times 2x minus 3, or minus that. So the first thing we would do here is change this using the definition of subtraction, which is x plus 6 equals x plus 6 plus negative 7. We'd write that in here, times 2x minus 3. Then this would be x plus 6. Negative 7 times 2x would be a negative 14x. Negative 7 times a negative 3 would be 21. We then combine like terms and get our answer. There is a really nice piece here about how you can check your answers when you're simplifying expressions. If you want to make sure that they're the same, you've got a number of different choices you can make. If there's just some variables in it, substitute values for the two variables in both expressions and make sure that they equal each other. If there's just one variable, you can graph it, or you can make a table and compare the table. So you got a lot of ways you could look at something when you're done and just check and make sure that it works out. When you do your substitution, be careful about using 1 or 0. 1 and 0 have properties that are a little different sometimes from other values in that they can be identities, and therefore they may not be helpful in doing your check. So you might want to choose a couple other values just to verify that. Your assignment for 2-4 is covering the ideas and applying the mathematics. You finish those, check them, bring it to me along with your notes. Get ready for your mastery quiz, which I will administer when you're ready. If you have questions, remember, come on in, write them on the board with your name. Let me know what you want to know about. And also check to see if there are any mini lectures being done on areas of interest to you. 2-4 examples. Here we've got a set of expressions, and we want to look at what's the opposite of the expression. So if the expression is u in this first one, then the opposite of u is going to be a negative sign u, opposite of u. The opposite of w, opposite expression is the opposite of w, which is equal to w. Now we've got a little bit more complicated one, u plus w. I want the opposite of the expression. That's this whole thing. That's the opposite of u plus w, which is equal to the opposite of u plus the opposite of w, which could be written as the opposite of u minus w. Next expression is u minus w. It's the opposite of u minus w. That equals opposite of u plus w. So this is the opposite of a sum here, and this last one we're doing the opposite of a difference. Next up is the opposite of u plus w. What is the opposite of that expression? Again, we put in the opposite sign, u plus w. This is like multiplying by a -1 using the distributive property. -1 times the opposite of u is simply u. -1 times w is the opposite of w. U plus the opposite of w. The opposite of that is here. And you'll see what we did right here was an op-op operation. We took the opposite of u plus w to get down to here. Okay, the opposite of a sum. Here, the expression there is its opposite. This is what we got for that. So the opposite of u plus w is equal to u plus w. The opposite of u minus w is equal to u minus w. So here are some opposites of expressions. I thought it would be useful to go through those first before we get into some more concrete examples. You should be confident with this, able to use the op-op property, able to use the opposite of a sum and opposite of a difference effectively, and understand how this is the use of a -1 in these calculations. Okay, so let's get to a more concrete expression. Simplify 7y minus, in parentheses, 2y plus 11. We will rewrite that as using the algebraic definition of subtraction. So 7y plus the opposite of 2y plus 11. And remember, this is like we have a -1 here. This is this negative. We don't write the 1 because there's only one 2y plus 11 in this, but it's there nonetheless. So this is 7y. -1 times 2y is the opposite of 2y. A -1 times 11 would be a -11. I've left this all as addition. I favor that because it is commutative and associative, and it allows me to move things around if I want to. Whereas if I had it as subtraction, I can't do that. So I feel that this gives me a little bit more flexibility in my calculations. Combine like terms, 7y plus the opposite of 2y, that would be 5y, only the one term there, plus the opposite of 11. We have an answer. I've circled it. This is the kind of work you want to show in progressing through to show this. First we used the algebraic definition of subtraction, then we used the opposite of the sum property, and lastly we combined like terms. Now this one, here we're going to go through one that's similar to the guided example. We're going to simplify w minus 3 minus 2 times 4w plus 2. First off, I want to use the algebraic definition of subtraction and change this into addition problem. So I've got w plus a -3 minus plus a -2 times 4w plus 2. This I can just simplify right away. I can remove the parentheses because this is like there's a 1 here. Multiplying through, I just get w plus a -3. Well, here I've got a -2. -2 times 4w is a -8w, and a -2 times 2 is a -4. My next step here is to combine like terms. So I've got my w terms, I've got my numeric terms. I'm going to combine those together. W plus a -8w is a -7w. -3 plus a -4 would be plus a -7, and we seem to be done. a problem and an error's been made, your job is to figure out where that error occurred. So describe the error or errors in the following example. Then correct the example. Well, in the first case, we've got, using the definition of subtraction, we've rewritten 2 times x minus 1 minus 3 times x minus 2 as 2 times x plus a negative 1 plus a negative 3 times x plus a negative 2. So that looks pretty good. So we've got that first step done. Now I'm going to carry on with this. I'd like for you to pause the video before I proceed and see if you can figure out where the error occurred in here and then how to write it correctly, how it would turn out correctly. I'll wait right here. Okay, welcome back. What'd you come up with? Did you find the error in this line, distributive property line, the opposite of a difference property, or the opposite of a sum property line? Let's take a look here. We wanted this result here should be a result of multiplication from our first line. So 2 times x is 2x. 2 times a negative 1 is a negative 2. That's good. Negative 3 times x is a negative 3x. And a negative 3 times a negative 2 is not a negative 2. So right here is our problem. They just carried this down and forgot to apply the distributive property to all of the terms inside of the parentheses. So what's this going to be? Negative 3 times a negative 2 is going to be 6. So our x's were okay. A negative 2 plus 6 is going to be just 4, which means this will be a plus 4. So here we've got it. We've figured out what happened. We've corrected it. This is a fairly common mistake. Be careful of it. Be aware of it. Remember to go back and double check if you've done it. That's it. Again, if you have questions, bring them to class. Love to talk to you about it. I'm looking forward to seeing you on the next lesson.